So we're looking at how to write the formulas and how to write the names of ionic compounds. Now, in order to do that, you have to first identify what an ionic compound actually is. At its simplest, an ionic compound is made up of a metal and a nonmetal. Well, okay, where do you find metals and where do you find nonmetals? How do you know which elements are metals and which elements are nonmetals? If you look on your periodic table, over here on the right-hand side, you have this stair-step line. It starts here with boron, in between boron and aluminum, and it just stair-steps all the way down. This is the dividing line. Now, the things that touch this are called metalloids, but everything to the left of this stair-step line are metals. Everything to the right of this stair-step line are nonmetals. So everything over here, except for hydrogen. Hydrogen's kind of over here on its own, and it's an exception to a lot of things, actually. And this is one of those things. So hydrogen is over here because of its electron configuration. It's in this column with the alkali metals because of the number of electrons it has in its valence shell and how it reacts. So it is an exception. So hydrogen is a nonmetal, even though it's over here on this side. Everything else on this side is a metal. Now, if you get confused by this, kind of look around and see what kinds of elements are in here. If you look, here's iron, here's copper, here's nickel. Most of us would look at these and say, okay, we know that iron is a metal. All right, so if iron is on this side and it's a metal, everything else over here must be a metal as well. So then everything over here on the right is a nonmetal. So when atoms form an ionic compound, what actually happens is one of the atoms gives up electrons to form a positive charge, and the other atom pulls those electrons in to form a negative charge. In general, what we see is that over here on the left, where our metals are, we're going to have our positive charge. Over here on our nonmetals, we're going to have negative charges. We can determine the total charge by looking at the column on the periodic table. Now, we've already done an activity with this, so we know that in this first column over here, the alkali metals and hydrogen form a positive 1 charge. We know that the second column, which is the alkaline earth metals, form a positive 2 charge. These are going to lose 2 electrons to form a positive 2 charge. Now, we're going to skip this section here in the middle. We'll come back to that here in a minute. This column here, with boron and aluminum and gallium, we are going to lose 3 electrons, and we're going to have a 3 positive charge. The carbon column, again, we're going to skip because it behaved a little bit differently. Nitrogen, phosphorus, arsenic, okay, these are going to form a 3 negative. These are the ones that are going to start gaining electrons. So when we gain an electron, we gain a negative. This column is going to gain 3. Oxygen, sulfur, selenium, this column here is going to gain 2 to form a 2 negative charge. And then the halogens, this group right here with fluorine, chlorine, bromine, these are going to form a negative 1. They're going to gain 1 electron. Now, this last column, remember, are the noble gases. Noble gases just don't bond very much, and they typically don't bond to form ionic compounds, at least anyway. So this column doesn't really form charges. So once we determine the charge, we need to decide how many of each one of those things we're going to need. So once we determine the charge, we need to decide if the positives and negatives are going to balance. Nature likes balance. We don't like to have charges. We don't like to have a buildup of charges. And so when we write our compounds, when we write our formulas for our compounds, what we want to do is we want to look at, are the charges balanced? So let's look at sodium sulfide for just a minute. Let's start with this one. So sodium sulfide, the first thing that we need to know is what are those symbols? Well, sodium on our periodic table is over here. This is one of the weird ones because it's Na, not what you would expect. So Na is sodium, so we're going to start with that. Sodium is in this first column, and this first column loses an electron to form a 1 positive charge. Sulfide is over here in the column with oxygen. This column gains 2 electrons to form a 2 negative. So sulfur has a symbol of S, and it has a 2 negative charge. Now what we want to look at is how are these going to balance? How are we going to write this formula so that we have the same number of positives as we do negatives? Well, if we have 2 negatives and 1 positive, all right, we have more negatives than we have positives, so we need more positives over here. Well, what happens if we come over here and add 1 more positive? All right, now how many total positives do we have here? If we have 2 sodium ions, we have 1 positive on each one of them, so then we would have a total of a 2 positive charge. And if we look at that, that would balance out with our 1 sulfur with our 2 negative charge. So to write this formula, in order to balance it, we would need 2 sodiums and 1 sulfur. All right? Now, by convention, just to make things simpler, if we write down a single atom, if we write down sulfur, we are going to assume that there's at least 1 sulfur in that compound. So this is actually incorrect. What we're going to do is we're going to write 2 sodiums and 1 sulfur, and we're just going to leave this little subscript blank. We're not going to write the 1. It just gets messy. So if we write down an element, we assume there's at least 1. We're not going to write anymore. Well, here's another one. Let's look at potassium. Oh, let's look at potassium chloride. Okay. So the first thing that we do, we're going to look on our periodic table, and we're going to find potassium. Potassium is in the same column as sodium. Potassium is K, again, one of those strange ones, but it's in column 1, and so potassium has a 1 positive charge. Chlorine is a halogen. It's over here in this end column with a negative 1 charge. It's going to gain an electron. So chlorine has a negative 1 charge. So if we look at this, we have a positive 1 charge with our potassium. We have a negative 1 charge with our chlorine. This one's pretty easy because it's already balanced. We just need 1 of each. So if we have 1 potassium and 1 chlorine, that gives us our potassium chloride. So this is the formula for potassium chloride. What about aluminum chloride? Let's make it hard now. If we have aluminum, okay, if we look on our periodic table, aluminum is right here. This is a column where we're going to lose 3 electrons. So the charge on our aluminum is 3 positive. Now we've already done chlorine. We already know. We don't have to look that one up again. All right, chlorine has a negative 1 charge. So what we have here is we have 3 positives and we have 1 negative. So we can add more aluminums, but we don't need to because we already have 3 positives. If we add another chlorine, all right, so now we have 3 positives and 2 negatives. Still not balanced, so let's add another one. So now we have 3 total negatives with our 3 chlorines that will balance out our 3 positives. So the formula for aluminum chloride is going to be Al, just one of them, Cl3. Let's stick with aluminum here, but let's do aluminum oxide. We did aluminum up here. We know that aluminum has a 3 positive charge. Now if we look at oxygen, oxygen is over here in this second column with a 2 negative. So oxygen has a 2 negative charge. All right, now this one doesn't just automatically balance. A lot of times we can't look at this and say, okay, we just need 1 more aluminum or we need 1 more oxygen, because we have fewer negatives than we have positives. But if we add another oxygen, oxygen has a 2 negative charge. So if we have 2 oxygens, this gives us now a total of 4 negative, which does not balance our 3 positive. However, if we add another oxygen, if we get another oxygen in here, now we have a total of 6 negative charges, which we can make 6 positives by adding 1 more aluminum. So if we have 2 aluminums, then we have 6 positive charges. And if we have 3 oxygens, then we have 6 negative charges. So the formula for aluminum oxide would be 2 aluminums and 3 oxygens. So in looking at ionic compounds, when writing the formulas for ionic compounds, first thing you need to do, write the symbols. Figure out what it is that you need to do to abbreviate those elements. Then determine the charge. Look at the column on the periodic table and determine what the charge is on that particular element when it becomes an ion. And then you just balance it. Once you have the charges, you can figure out how many of each one that you need in order to get the same number of positives as you have negatives. All right, now what if we have the formula, but we want to name it? So when we name these ionic compounds, what we're looking at is, let's just say we have, let's go calcium with chlorine. So if we look at this formula, we have calcium and we have chlorine. In order to name this, we have to go back to our periodic table, find the symbol, so here's Ca, and that is calcium. So we're going to write calcium. And we come over here and we find Cl, which is chlorine. So what we have is we have calcium bonded with chlorine. Now what happens is when we write these formulas, anytime we write the formulas or the names, the positive ion goes first. So calcium has a 2 positive charge, so this is going to be the one that's written first. We do the same thing in our naming. So that positive ion is written first. The negative ion is written second. The negative ion gets its ending changed. So what we're going to do is we're going to change that ending to IDE. So instead of chlorine, instead of saying calcium chlorine, we're going to say calcium chloride. So the name for this particular compound is calcium chloride. What if we have these two? Well, if we look on our periodic table, we have an SR right here, and we can look up the name, and it is strontium. O, we probably know already, is oxygen. And we're going to change the ending of oxygen to IDE. So instead of saying strontium oxygen, we have strontium oxide. What about Mg? Oh, let's go P, which that's not right. What if we have Mg3P2? Again, if we're looking on our periodic table, Mg is right here. This is magnesium. P is over here, which is phosphorus. So changing the ending of phosphorus to IDE, we're going to have phosphide. What if we have Na3N? Well, Na is sodium, N is nitrogen, so we will have sodium. If we change that ending to IDE, we will get nitride. So sodium nitride, magnesium phosphide, strontium oxide, calcium chloride. The second one that we write is the negative ion, and that ending gets changed to IDE.